The way low-pass filters work is that you have a frequency designation, say above or below the 20-meter band, and it lets everything below that frequency designation pass through the filter. Everything above that attenuates the signal, and you do this to have a cleaner, more pure signal. This one's adjustable, as I mentioned, between 20, 30, and 40. Now, this is a kit. I'll have a link to the kit in the description. It's relatively inexpensive. I got it off of AliExpress. In this video, I'm going to show how I put it together and what we did. And then we're going to connect it up to a Nano VNA, and we're going to do an S21 gain measurement. And we'll be able to see the performance of this device and how well it works. Now, if it doesn't work well, there could be a couple of things. It could be the quality of the components. It could be the construction. It could have been something that I did. And typically, you have to do some adjustments. In this case, maybe I have to replace a couple capacitors. I don't know. Also, sometimes you have to move the windings, either compress the windings, expand the windings, or add a winding or remove a winding. So we'll get it tested out and we'll see what happens. All right, folks, so here's everything that's shipped with the low-pass filter kit. The first thing is that we have this circuit board, and it looks to be pretty nice. It has everything marked where your different capacitors will go. I'm not how sure you can see it right now, but we'll get a better look at this. But they're marked C1, and your inductors are like, here's an L5, for example. And then here is the spot for, we might as well just show this one, the BNC connector that's going to go on here. One on either side for signal in, signal out, labeled RF in and out. It comes with 6 toroids. We have 4. These are T2 and these are T6. They're both powdered iron toroidal cores. And I believe that these are 68 millimeters, but I'm not 100% sure. Maybe I'm wrong about that. Here are the switches. These go on either side here. They're 3-position switches to switch between the bands 20, 30, and 40 are the bands that we have. And then this is kind of cool, but it's kind of not. Like if you take a look at this, see how teeny these capacitors are? So that's going to be a real job for my eyes. But it's labeled. They're all labeled. This one's C2. This one's labeled C6. And so that'll make finding them on the board pretty easy. This thing did not come with any instructions. On the website, I was able to find, and I'll roll a picture in, how many times we wrap each one of these toroids. And that's cool and all, but I sure would like to have the inductance value so I can measure it with a meter and make sure that I'm accurate. They did give me some magnet wire here. And while this magnet wire is awesome to be included, I'm not sure if any more of this size, and the instructions don't tell me how long to cut it for wrapping the toroid. So hopefully I don't use it all up and run out and have to use a different gauge, because that could cause some inductance variance, and I'm not interested in that. All right, well, let's get to building. Okay, so here we are zoomed in on the board a little bit, and this is actually nice because I can actually see this on my screen and I don't have to use my glasses, but I still might break out the magnifying glass. So if you take a look here, this is C1, 3, and 10, and you can see these little itty-bitty capacitors. So what I want to do is I want to open this bag, and this is always the worst part, is getting these bags opened up. I don't have my scissors. Somebody came down here and borrowed them, and now they're missing. So what I want to do is for a C1, and these capacitors don't have any particular orientation. So I just want to go ahead and I want to put this in the holes for C1. Now, I want to be really careful with these capacitors. And the reason being is that they are ceramic capacitors, and when you go bending the legs and twisting them up, you can cause some damage. So what I like to do is I like to flip it over and gently bend them a little bit each direction. And that'll hold that in place until we go ahead and we solder those to the board. And I always mix this up. This is a really handy holder device. I don't know what you call it, a proto board grip. I don't know. But I'll put a link to it in the description because everybody asked me about it. So that is number 1, and now we need to find capacitor 3, and that looks like it's over here. So let's go ahead and take another one and just drop it in capacitor 3. And again, it would be nice to have the values. Now I can look at these capacitors. I probably have to do it under a high definition microscope because they are so small, but they have a little number on them, and then you can actually use that number to look these capacitors up in the event that you needed to buy one because you lost one or something like that. Well, if you lost it, you wouldn't have the number off of it. Let's keep on rolling, and then we have capacitor 10. And that looks like it is right here. Let me see if I can put this magnifying glass on there, and if that changes it. Yeah, you can see the 10 right there. So let me go ahead and get this number 10 in real quick. All right, and we're ready to do our first soldering. So let me get the solder iron fired up, and we'll be right back. All right, and we're back, and you can probably hear some hum on the microphone, and that is my solder iron causing some interference to my audio system. So what we're going to do is we're just going to go ahead and we're going to solder these quickly. And hopefully they don't look too bad. I can't see them so well looking at the board, but in the camera I can see them pretty good. So what I like to do is I like to use a chisel tip iron. I find it works well for me. Maybe I don't know what I'm doing. And then I just want to put this solder right up to the edge of the hole. I use the iron to kind of heat the leg of the device, or the leg of the component, and the hole. And then I just hurry up and I touch that with my solder iron and I pull it off. And I get a little bit of solder in there. I want to make sure I don't bridge these or make a mess or anything like that. So anyhow, I'll just do this real quick. It's a little difficult seeing that far away, but that's okay. There we go. Not too bad. And then what I like to do as I progress with the project is I just come in and I snip all these legs off. Now, I should be having eye protection on. This is kind of dangerous because these legs can go flying everywhere. So what I like to do also is like to hold or pinch the leg of the component, the excess, as I'm cutting it, because it is less likely to go flying around the room. Now, some people save these legs and they put them into a jar and they say, I have them legs in case I ever need. Sometimes I have had to use a leg to make a lead or a jumper or something like that, but it's extremely rare. Maybe I don't solder enough. I don't know. But I got enough junk around here that these are just going straight in the trash. I'm not that worried about it. Now, because I know I'm a great solder person and you love to watch, but I'm going to deprive you of the joy of watching me finish this up because I don't want to make the video longer than I need to. So I'm going to go ahead. I'm going to put all the capacitors in here, and I will be back when I'm done. All right, folks, and here is the 12 capacitors that we put on there. Ooh, look at that. And let me get, I know some of you guys like to see the underside. I'm not sure if that's going to convict or what is it, convict or redeem me, the soldering there. So anyhow, that is that, and now it's time to put some other parts on. And what I like to do is start with the small parts and then move to bigger parts. We're going to do the toroids last. I think we're going to do the toroids last. I haven't decided yet. But next I want to do these switches. These, as I mentioned, are 3-position switches. And sometimes they take a little finagling to get in here. But I think if we just line this up and we take our time, there we go. This seems to be holding itself in place. Typically, I use something called blue tack. It's kind of like a silly putty to hold stuff like this in place. But the problem is I can never find the blue tack when I'm soldering, only when I'm not soldering. And as a result, I typically end up using masking tape. But let me go ahead and solder this on real quick. And what I like to do is just tack down one corner first to kind of hold it in place and then work through the rest. I don't know if that makes sense or not. And that doesn't look too bad. None of them are touching or bridged, and I think we're good to go. I'm going to go ahead and do the other one off camera because I'm so shy. All right, so you can see that the switches are now on. Doesn't look too bad. The next thing we're going to do on here is solder on these BNC connectors. And let me just go ahead and get this one on here. And I believe we're going to have to use the tape. Well, maybe not. I was thinking we were going to have to use the tape for that, but that doesn't look like it. I should really be wearing my glasses for this, but I'm not. Now down here, these pieces are going to take a lot of heat to get going. That's just the way it's going to be. And that one still looks like it could use a little more. And I'm not sure what the deal is with him. All right, I think we're good. All right, I'm going to put the other one on, and then I'm going to come back when we're ready to start toroid wrapping. And there we go. So far, so good. Now, I'm going to get the toroid stuff set up, and we're going to come back and we're going to do that. I will include a link to this website below, but this is the most of the instructions that we get with the kit. And I was mistaken. If you look at the chart here, you can see that they do give the values for the capacitor. So C1 is 330 picofarad, which is super handy if you lost one or damaged one or have a problem and need to troubleshoot. Now down here you'll see L1 and L2. That is inductor 1 and inductor 2. Over here you have inductor 3, inductor 4, inductor 5, and inductor 6. And for 1, it tells you that it is T50-2. So earlier I said that these were 63 millimeters. I don't know what I was thinking. I was probably hungover. But when you look at it, so T50 means toroidal core shape, a toroid at 1/2 inch in diameter. And then 2 is the mix. In our case, this is a powdered iron and happens to be red. Over here for L5, T50-6 would be the yellow mixed powdered iron core. Now you see after the designation of the toroid, you have 16T, down here you have 19T. That means that you do 16 turns or 16 wraps with the magnet wire that's supplied with the kit. Hopefully that answers everybody's questions and is helpful. So what we have here is L1, and it is the mix to toroid that we talked about earlier with 16 wraps. Each time the wire goes through the center of the toroid, that is considered a turn or a wrap. Thus, this would be a 16T. All right, folks, and so it's a different day, and we're back. And what I've done is I've just wrapped all these toroids. It's pretty simple. You just wind the wire through, and you keep going around for the number of turns it was designated on the chart that we looked at. I did run out of wire, so these 2 yellow ones, I used this B&Tech Go, and this is 28 gauge, I believe is what it is. I can't read that. And it's a little bit fatter than the wire that came with it, but I think it's going to be okay. And what I've done is as I've wound these, I just labeled each one inductor 1, inductor 2, inductor 4. And the thing that I wanted to mention is that this magnet wire has an enamel coating on it. And so what I do is I use this razor blade to kind of gently scrape that enamel coating off. And then here you can see this is inductor 6, which goes right here. And so what we want to do is that after we scrape that off, I'm just going to go ahead and I'm going to cut these. And then you just want to go ahead and put this into, like I mentioned, the spot for inductor 6. And this is going to take forever. Once I get it in, I go and I push it down like that, flip it over, and then like when we did the other components, I just want to bend these, and then I'm going to go ahead and I'm going to solder that to the board. Then I'm going to go up and I'm going to do that for each one of these. I'm not going to show all that on video because this video is starting to get a little long, so I will come back once I'm done this process. All right, folks, so this is the finished product here. I have not cut the legs off of the inductors or the toroids because I may need to take them out and adjust them or something like that, and I figured it would be easier if I had the legs on there. Taking a look at this, what we want to do is we want to do a measurement, an S21 measurement on my Nano VNA. And so what we're going to do is we're going to hook it up to this calibrated Nano VNA. And what we do is when we calibrate for tests like this, we calibrate to here as our reference plane, not here on the Nano VNA. And we do that so any reactants, any inductive or capacitive reactants introduced by these cables won't be considered in the frequency response that we're measuring on our filter. The other thing is that we'll measure from here, get our frequency response, and any potential insertion loss introduced by this device. We're going to use software to do this called Nano VNA Saver, so we don't have to worry about zooming in on the screen of the Nano VNA. I'm going to get everything connected, set up, and I'll be right back. Okay, before we fire up the software, I'm going to show you what we have set up. Here's our Nano VNA. Basically, what we're doing is squirting RF out, channel 0, in through our device, which will do the filtering, and then a frequency will come out and back into channel 1 of the Nano VNA, and that's what we're going to measure called S21 gain. And let's go over and take a look at the software and see how it's going. All right, here we go with Nano VNA Saver running. If you look up here in the top left-hand corner, there is a set of panels called sweep control. And what we have is we are running a sweep from 0.5 megahertz or 500 kilohertz all the way up to 50 megahertz. And I just kind of randomly picked that before I did the calibration because what I wanted to do is make sure that we capture enough spectrum in order to see what we're trying to measure here. One of the things you'll notice, I have 10 segments set up, and I've also configured Nano VNA Saver for 401 data points, which means we're going to get a little over 4,000 data points across our span of 49.5 megahertz. What that boils down to is one data point every 12.35 kilohertz, and that's pretty good. We're going to do that for our sweeps. So what I'm going to do now is I have the filter set for 20 megahertz. So I'm just going to go ahead and I am going to click sweep. Now, because we have so many data points, this is going to take a while. We'll come back when it's done. Okay, so what we have here is our marker, and I've set that at the negative 3 dB point. So when you run a signal through a filter and you start to get a roll-off, that's when your signal drops. Once it hits 3 dB, that's considered the effective range of that filter. And so here we're actually at 2.999, and that's the closest I could get with the number of points that I have. When I take a look at this, the frequency for that is 13.6619. And so that means that our roll-off is below the 20 meter band. And that would mean that if we wanted to capture 20 meters and below, we're not really going to capture that at the best way that we can. Now, there could be a couple of things. I think I mentioned that there's some adjustments that could be made. The number of wraps, the proximity of the wraps to each other, maybe you expand or contract that. Or maybe even replace the capacitors with ones that are a little bit more close to the desired values. But no, this isn't bad. This is a really good starting point and will give us something to work with. What I'm going to do now is I'm going to adjust the filter to 30 megahertz, and I'm going to run the sweep, and we will be back once the sweep is run. Okay, here for our marker, we've adjusted it. Now we have an S21 gain for this marker at negative 3.014, and that's as close as I could get it. And the frequency for this is 7.574. And so when you take a look at that and you say, well, is that really 30 meter band? No, it's not. This is about what you would expect to see for the 40 meter band. So again, it looks like there are some adjustments that need to be made here. Let's go ahead and do the sweep for 40. And here we have our marker adjustment for the 40 meter setting, and we are at negative 2.990, was as close as I could get it to negative 3 dB. And when you take a look at the frequency for this one, it's 6.8, which is below the 40 meter band. So in all of these cases, our filter is activated, or the frequency response that we're looking for is below the desired bands. Is it a big deal? No, I don't think so. It's just some more work on the project and something to tinker around with. And folks, that's going to wrap it up. I want to say thanks to everybody for watching. I really appreciate it. If you have any questions, comments, suggestions, or recommendations, go ahead and post them below and I'll do my best to respond. Thanks again.